Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about transmission medium and its types. Transmission media refer to the physical pathways through which data is transmitted from one device to another within a network. These pathways can be wired or wireless. The choice of medium depends on factors like distance, speed, and interference. The transmission media is broadly classified into guided and unguided medium. Guided media is also referred to as wired or bounded transmission media. Signals being transmitted are directed and confined in a narrow pathway by using physical links. The features of guided media are it's very high speed and secure, and it's used for comparatively shorter distances. The three major types of guided media are twisted pair cables, coaxial cables, and fiber optic cables. Twisted pair cable consists of two separately insulated conductor wires wound about each other. Generally, several such pairs are bundled together in a protective sheet. They are the most widely used transmission medium. Twisted pair cables are further classified into shielded and unshielded twisted pair cables. Shielded twisted pair cables consist of a special jacket, which is nothing but a copper braid covering or a foil shield to block external interferences. It is used in fast data rate Ethernet and in voice and data channels of telephone lines. The advantages of shielded twisted pair cables are it provides better performance at a higher data rate when compared to unshielded twisted pair cables. It also eliminates crosstalk and also very fast when compared to unshielded twisted pair cables. Disadvantages of shielded twisted pair cables are it is very difficult to install and manufacture, and it is very bulky and expensive. Next one is unshielded twisted pair cables. So here it consists of two insulated copper wires twisted around one another. This type of cable has the ability to block interference and does not depend on physical shield for this purpose. It is used in telephonic applications. Advantages are it's less expensive when compared to shielded twisted pair cables. It is easy to install and provides high speed capacity. The disadvantages are it is susceptible to external interference, lower capacity and performance in comparison to shielded twisted pair cable, and short distance transmission only is allowed due to attenuation problems. Next one is coaxial cable. So it has an outer plastic covering containing an insulation layer made of PVC or Teflon and two parallel conductors, each having a separate insulated protection cover. The coaxial cable transmits information in two modes, which is baseband mode, dedicated cable bandwidth, and broadband mode. Cable bandwidth is split into separate ranges. Cable TVs and analog television networks widely use coaxial cables. Advantages of coaxial cables are it supports high bandwidth and it's easy to install. Also, it has better cut-through resistance, so they are more reliable and durable. It is less affected by noise or crosstalk or electromagnetic interference. Coaxial cables also support multiple channels. The disadvantages are it is very expensive and it must be grounded in order to prevent any crosstalk. Coaxial cable has multiple layers, so it is very bulky. There is a chance of breaking the coaxial cable and attaching a T-joint by the hackers. This compromises the security of the data. Next one is fiber optic cable. A fiber optic cable is made of glass or plastic and transmits the signals in the form of light. If a ray of light traveling through one substance suddenly enters into another substance, the ray changes the direction. So this fiber optic cable works on the principle of total internal reflection. So here's the figure which shows how a ray of light changes the direction when going from more dense to a less dense substance. When the angle of incidence is less than the critical angle, the ray will be refracted, and when it is equal to the critical angle, it will be passing along the surface, and when it is greater than the critical angle, the ray will get reflected back into the more dense medium as shown in the figure. Optical fibers use reflection to guide light through a channel. A glass or plastic core is surrounded by a cladding of less dense glass or plastic. The difference in density of the two materials must be such that a beam of light moving through the core is reflected off the cladding instead of being refracted into it. So this is a construction of fiber optic cable. So it consists of a glass core, a cladding, a plastic buffer, and an outer jacket. So the outer jacket is made up of PVC or Teflon. So inside the jacket are the Kevlar strands to strengthen the cable. So it is a strong material which is used in bulletproof vests. Below the Kevlar, another plastic coating is present to cushion the fiber. The fiber is the center of the cable with core and cladding. So the advantages of optical fiber are increased capacity and bandwidth, and it is very lightweight and less signal attenuation and immunity to electromagnetic interference, and it has resistance to corrosive materials. Some of the disadvantages are it is difficult to install and maintain, and it is very high cost. Next one is unguided medium. It is also referred to as wireless or unbounded transmission media. No physical medium is required for transmission of electromagnetic signals. The features of unguided media are the signal is broadcasted through air, and it is very less secure, and it's used for larger distances. The types of unguided media are radio waves, microwaves, and infrared. Radio waves are easy to generate and can penetrate through buildings. The sending and receiving antennas need not be aligned. Frequency range of radio waves is 3 kHz to 1 GHz. AM and FM radios and cordless phones use radio waves for transmission. Next one is microwaves. So it is a line of sight transmission, that is, the sending and the receiving antennas need to be properly aligned with each other. The distance covered by the signal is directly proportional to the height of the antenna. Frequency range of microwaves is 1 GHz to 300 GHz. Microwaves are majorly used for mobile phone communications and television distribution. Next one is infrared. Infrared waves are used for very short distance communication. They cannot penetrate through the obstacles. This prevents the interference between the systems. The frequency range of infrared is 300 GHz to 400 THz. It is used in TV remotes, wireless mouse, keyboards, printers, etc. Hope you understood the different types of transmission medium. Let us take up some assessment questions. In a twisted pair cable, the gauge of the wire and the type of the twist determines the quality of transmission. When the angle of incidence is equal to the critical angle, the light beam bends along the interface. Dash consists of a central conductor and a shield. Yes, it is the coaxial cable. Thank you for watching this video.